Okay, so this is a week 7, the number 3, the topic on functional group in organic molecule. The first problem is essentially name the family to which of the following compound belongs to. So it is actually kind of interesting that they say the name the family of the organic compound is showing below, but also we can identify what kind of functional group that is related to this responsible family of the classes. And I also use this as an opportunity to draw the bond diagram for this molecule here. And before we begin, I'd like to talk about the functional group. Functional group is something that is responsible in organic chemical reaction, and that is essentially has electron-rich groups, right? So typically, I would say something like a double bond, and which has electron-rich, or something with lone pairs, right? So if you think about lone pairs, that is an example of nitrogen can have a lone pairs, oxygen can have a lone pairs, right? So these are the example, and we can see that everything has its own name for historical regions and nomenclature regions. So first compound A is, I can draw 3 carbon, and this first carbon and second carbon has this double bond. So this is the right carbon, the 3 carbons here, and then the second carbon, right? Okay, so this is what we call alkene. Okay, it's an alkene. So number B, which is a 2 carbon with an OH. So 2 carbon, there's 2 carbons here, and 1 carbon is connected by OH group. And this is what the family called alcohol. Okay, and number C, you see here there are 3 carbons here. So this is a 1, 2, 3, and this one has a double bond, and then this carbon is connected by oxygen, and then there is one stick coming out, and that is a methyl group. Right? And then this one, the key functional group here is actually this the one with, right? So this one has a lone pairs here. This one does have a lone pairs. Also, this one has a lone pairs, right? And this one we call the Ester group, Ester family. So Ester family is particularly responsible for the COO bonding in the middle of the molecule. And ester is being made from this compound. It looks like this. That's an organic carboxylic acid, and this one made out of the four carbons. So number D, 1, 2, 3, 4. So those are the 4 carbons, and then you're going to put the double bond and OH. And this is we call the acid. Sometimes people call. There are different kinds of acid. This is based on the carbon base, so carboxy base, so carboxylic acid. So this is an acid that kind of we call it a weak acid on that. So the E is there are 4 carbons, and then this amine group is actually connected to this carbon in here. Okay, this amine group is connected to that to do that. So I'm going to draw the 1, 2, 3. Those are the 3 carbons, and the last one is connected by NH2. And once again, this one has a lone pairs here for the nitrogen. That's what functional group is about. This is also electron rich, and this functional group because of the lone pairs are quite a lot around here. The last one here is actually, it just looks different, but it has a lone pairs. This 3 carbon molecule is connected by OH. And if you're looking at this ethanol, this is a propanol. This is essentially the same kind of class of compound. Okay, so F is, I can draw the other way, like 1, 2, 3, and you can put HO here, right? But this is essentially the same as when people say 3 carbons with an OH connected to the other side. So this is what we call alcohol. Oh, and the E, by the way, is amine, is we call the amine. Okay, so it's kind of the name comes from the ammonia, right? So that's where it's coming from. And one extra thing that also we want you to know is kind of identify the functional group here. So within this class of families that we have, so I'm going to highlight the functional groups here. So this is a functional group. We call that's a double bond. And this is an alcohol. And this is a hydro. Right? This is hydrogen, and then there is an oxygen, so hydroxyl. So this is an hydroxyl group that we call this, and this is a COO, and that is what we call Ester Group, and COOH, that is a carboxylic acid. We call just a acid group. Okay. Just call that as an acid group, and this is essentially amine, group, okay. Acid group, carboxylic group. It's actually the funny one is we call this is a carboxylic group. But it's also, we call this is OH as being hydroxy. They just call it the other way, going back and forth. Okay, so this is a hydroxyl group. Okay, as an adjective, they put an L there. As a name itself, that's an hydroxy group, hydroxy compound. The second portion of the functional group is the name the functional group present in the following structures. So in this group, I like to identify by actually showing the lone pairs here. There are 2 lone pairs, implied lone pairs. There's a lone pair here. So therefore, this one is what we call the oxygen with kind of carbons on both sides, right? So that's what we call the ether. So that's an ether. And this is an amine on both sides, and still we call this is an amine. But this is a case of particular we call the secondary amine. And I don't think that you need to know this far, but that's a secondary amine. When the amine NH2 with carbon-based compound, and this is what we call the primary amine. That's a commonly known as one, but if amine can have NH, as you shown here, with the 2 carbons being connected, and this lone pair containing nitrogen, that's a secondary amine. And I guess you guys can already make a guess. If it was 3 carbons are being connected, it's a tertiary amine. And you get to learn about the different types of amine later when you are taking organic chemistry. Okay, so once again, this is another one. These carbons and oxygens are being connected like this, and so there's 2 lone pairs, and this is the same thing as before. This is an ether. So now, this is the nitrogen, but nitrogen is connected to the carbon. But that carbon is not a normal carbon, but sp2 type of carbon with a carbonyl group. So this itself, we call this is a amide, which is a, think about, do you remember this one? Right? That is, we call ester, and this is an amide, and so that's kind of similar things. When you learn soon about the polymer component, this is actually coming from the polyamide and the polyamide, and the polyamide is essentially coming from the nylon, and this is essentially basic bond in the polyester, means a lot of polyester. That's what that means. Okay, so moving on to the next topic, and then this is the one that now we see this another cyclic compound, but you just need to more focus, pay attention to the one that with lone pairs. So this is a lone pair, so obviously this is getting into the functional groups, and I can start to circle that. That looks like an ester, right? That's good. And then this one is lone pairs. So this is a source of the another functional group, and this one starting from here, that it looks like, and then this is a carbon base, right? So I mean I can write it as something that connected to R, carbon, with CO and H, right? With those. So this compound we call aldehyde. Okay, so that's an aldehyde group. So there's ester, and the aldehyde group is shown up here. The last one is, okay, so what do you see? I see the oxygen with a lone pair, so that must be a source of functional group, and it's connected to this way, so that is, I see here, that is ester. Okay, once again, this is a ROCOR. To your mind, that is a ester group that connect, making one the functional group. And to the other end, and this one a COOH connected to R. So this is more like R with COOH, and that is what we call the acid group. Okay, carboxylic acid. Carboxylic acid. If you want to be more precise in describing about this. So the organic chemistry starts with identifying some kind of the functional group that can have reactivities, and then once you figure that out, and then for example the carboxylic acid with alcohol result in ester, and the byproduct is water, right? So ester being formed from the carboxylic acid and the alcohol. Second one is when the COOH, carboxylic acid, react with NH2, which is an amine, primary amine, then you will have CONH with an R prime, right? And then there's an amide bonding that you see. This is an amide, and this is an ester. Okay, so this is just the languages how acid, amine react with amide and the water. So does up acid, carboxylic acid react with alcohol. You generate an ester with water as a byproduct. Okay, so that's how the organic chemistry reactions and amine in amide is made from acid with some compound with a different functional groups. Okay, thank you for your attention, and I hope you have a smoother start on the organic chemistry, and this is a little helpful to you. Thank you very much.